Namaskar. Warm welcome to the whole of Maharashtra. You are watching Ashish sir on JKSClassesonline.com. You are on JKSClassesonline.com. Today we have come down to the last topic ka LMR chapter 8, differential equation and its application. I hope you must have enjoyed the small cameo journey of all the chapters ka LMRs up till here, and it must have been really useful to all of you as far as the last minute quick revision is concerned. But coming back to this topic, I have fragmentized the entire topic into this many segments, as in the last one goes application of differential equation. But to start with, the very first thing, the order and the degree of the differential equation. Warm welcome to all of you. First of all, differential equation, what is a differential equation, or what type of equation do you happen to call it as a differential equation? Any equation which contains dy by dx or the higher order derivatives and the two variables, the x and y, the independent and the dependent variable. Such an equation is called as a differential equation. As you can see right now on the board, the very first equation, it is a differential equation. It contains dy by dx, it contains the second order derivative d square by dx square, if I am not wrong, yes, and the two variables x comma y. So, any equation which contains any of this, they happen to call it as any equation which contains any of this. They call it as differential equation. Now, coming to the order and the differential equation, now that may be really useful to you in your MCQ type questions. They may happen to ask this in the MCQ type questions. Now, what is the order of the differential equation? The highest order derivative in the differential equation becomes the order of the differential equation. Technically thoda heavy. The highest order derivative in the differential equation becomes the order of the differential equation. As in, you can see over here in the first one, the d square y by dx square, and we have got dy by dx. So, the highest order derivative involved in this is the second order derivative. So, we say the order of the differential equation happens to go to the second order derivative. So, the order of d is 2. Can I repeat the line? The highest order derivative in the differential equation becomes the order of the differential equation. If you see the first one, the highest order derivative involved in that is the second order derivative, and therefore the order of the differential equation happens to go 2. Similarly, the next one also, let us first finish off the order and then we move on to the degree of differential equation. Second equation also contains first order derivative and the second order derivative. So, we do happen to say the order of the differential equation therefore happens to be 2. How? Sir, आपने बोला the highest order derivative in the differential equation becomes the order of the differential equation. In your second equation, the highest order derivative is the second order derivative d square y by dx square, and therefore the order of the differential equation does happen to become 2. Now, the second one, the degree of the differential equation. The highest power of the highest order derivative, oh gosh, the highest power of the highest order derivative in the differential equation, given that the differential equation is free of all the fractional indices and the negative powers, that power becomes then the degree of the differential equation. Pretty confusing. The highest power of the highest order derivative with the differential equation free of all the fractional powers and the negative indices, then becomes the degree of the differential equation. So, if I just cut down the last part, free of fractional indices, that I have given you one example over here, we will come to that. The highest power of the highest order derivative, or the power of the highest order derivative, becomes the degree of the differential equation. Power of the highest order differential equation. So, if I see the first one, the highest order derivative was the second order derivative, and then its power was 4. So, we say the degree of the differential equation of that differential equation needs to go 4. It is of degree 4. Can I repeat the definition? The power of the highest order derivative. Now, both have got the powers, but we need to talk about the power of the highest order derivative. So, the power of the highest order derivative was 4, and that becomes the degree of the differential equation. Now, over here, before you decide the power, of the highest order derivative, you need to free the differential equation from all the fractional indices. Now I see cube root over here. Now basically cube root bolega to it's the whole raised to 1 by 3. Now differential equation first needs to be freed of this fractional indices, and then you decide the power of the highest order derivative to decide the degree of the differential equation. So I think a very simple way of getting rid of that cube root is cubing on, when you want to get rid of square root, you happen to go squaring on both sides. So when you happen to eliminate your cube root over here, or if you want to free your differential equation of this cube root, you need to cube on both sides. So when you cube on both sides, probably I think so it becomes the whole cube and the cube root सामने से जाएगा. No, when you cube the cube root is going to go. No, square root on squaring goes. So cubing the cube root is going to go. So we say cubing on both the sides. Now I think so we are in a position. Now the differential equation what you are seeing is free of your fractional indices. That was what the definition said. Now after freeing your differential equation of all the fractional indices and the negative powers, if at all, involved in the differential equation, then the power of the highest order derivative what you see then becomes the degree of the differential equation. Am I confusing? Yes sir. After freeing samajhte azadi, after freeing the differential equation of its fractional indices, what we just now happen to do it over here. No, we cube on both the sides so that the differential equation then becomes free of that fractional indice 1 by 3, it was cube root. After freeing that, after freeing the differential equation of all the fractional indices and the negative powers, it was not there in this case. So then you look at the power of the highest order derivative, as in right now. The highest order derivative d square by dx square, uska power 3, that becomes the degree of the differential equation. So basically it is the power of the highest order derivative which becomes the degree of the differential equation if you want to make it short, and students do try to make it short to quickly identify the degree of the differential equation. Can I punch those words once again? The power of the highest order derivative in the differential equation becomes the degree of the differential equation, as in this case the degree now becomes 3. The degree becomes 3 because the highest order derivative was the d square by dx square, uska power 3, that becomes the degree. Upar highest order derivative once again d square by dx square, and then uska power 4 becomes the degree. And who becomes the order of the differential equation? That was pretty simple. The highest order derivative in the differential equation becomes the order of the differential equation. So probably I think this was quite comfortable, the first one. Let's look into the next one please. Coming to the second part, second segment now, form the differential equation. Can I take an example over here? Let us say I have a solution over here. I have a relation between the two variables y and x, y equal to ax plus b. Now how to form a differential equation? You differentiate for the first time. You reach to what? Dy by dx is equal to a. The x goes 1 and the b goes 0. Then you differentiate one more time, d square y by dx square. I hope your derivative still is in the right place. Now when you differentiate second time, that means when you are differentiating your dy by dx with respect to x, it becomes a second order derivative, d square y by dx square. That becomes 0. Now this is called as the differential equation to the given equation. Now that's called solution and that's called differential equation. So I do understand when you want to come from solution to differential equation, you will have to differentiate. And then when you want to go back to the solution, we have got in our syllabus the two-way channel. From solution they ask you to come down to differential equation. You just now saw with this small example, you need to differentiate. We will then come to the particulars also, the technicalities involved in this. When you want to go back from the that's your second part of the topic. From differential equation you need to go back to the solution, so anybody can figure out it's going to be integrate. So from solution you differentiate and you come down to the differential equation. From differential equation, if you want to go back to solution, you have to go antiderivative, which is integration. So you have to integrate and go back to your solution. So two parts in the topic, and I think so that segments do happen to talk about both the things. But now more importantly, I observed something over here. While forming D, I was trying to eliminate the arbitrary constants A and B. Arbitrary constants because they can pick up any values. Now, it is not a fixed constant. I did not write 5x plus 6. I wrote Ax plus B. So, A and B can pick up any values, and that is why the name goes arbitrary constants. But coming to the main thing, when you were forming the differential equation, I just observed that we were trying to eliminate the arbitrary constants A and B. And that is why the rule happens to go in this way, that you are allowed to differentiate only that many times as many arbitrary constants are there in the given solution. As in the solution I had 2 arbitrary constants A and B, so I was allowed to differentiate 2 times to get rid of my arbitrary constants A and B, and once I reach to that, that becomes my differential equation. And that is why in questions you must have observed that they do happen to ask you form the differential equation by eliminating the arbitrary constants. And to eliminate the arbitrary constants, the best way is to differentiate. Anyway, the differential equation does happen to contain dy by dx and the higher order derivatives, as you can see right now over here. So, now can I take you into 1 or 2 examples of how to form a D, but can we conclude something over here? When I ask you, or when the question happens to ask you form the D, you got it, you have to eliminate the arbitrary constants. Somehow that constants need to get eliminated before you reach your differential equation, before you claim the equation what you got by differentiating is the differential equation. Okay, that. Second thing, how many times you are allowed to differentiate? You are allowed to differentiate only that many times as many arbitrary constants are there in the equation. So, now with that I would like to take you into 2 nice examples. Examples say I think it becomes more quick to understand, and it also helps in the last minute revision. So, my solution goes in this way, my equation happens to go in this way. Let us say I have got y a raised to x plus b e raised to minus x. Now, form the differential equation by eliminating the arbitrary constants. By eliminating the arbitrary constants, and when I look at my solution over here, थोड़ा सा fear creep in हो जाता है, थोड़ा सा डर लगने लगता है, because your a and b are standing by the side of e raised to x, and e raised to x are so powerful functions that you differentiate n number of times, your e raised to x is always going to be there as e raised to x. That means मैं अगर अपनी भाषा में बोलूँ तो a and b हमेशा सुरक्षित रहेंगे. They are standing by the side of that functions which don't happen to deteriorate or disintegrate when you derivate the thing. No, it's not like your x square, which on first derivative becomes 2x, on the second derivative it becomes 2, on the third derivative it becomes 0. खलास हो गया. वैसा आपका e raised to x नहीं, e raised to x you differentiate n number of times, it's going to stay e raised to x. तो तू बोलेगा सर आपको प्रॉब्लम क्या है? प्रॉब्लम ये है, that means we will never be able to touch your a and b. And if you are not able to touch your a and b, then in that case it becomes very difficult to eliminate the constants a and b. I hope you can understand that. But then I just thought of what I am allowed to do over here. I am allowed to differentiate 2 times. So at least I can differentiate, in spite of knowing I will not be able to touch my a and b, but because I was allowed to differentiate 2 times, so I just started my sum. The question stands, form the differential equation by eliminating the arbitrary constants. So in the end I should be having second order derivative because I am going to differentiate 2 times, and the equation must be free of a and b. Let us see we will be able to do it or not. फिलहाल तो नहीं लग रहा है, because whenever I am going to differentiate, the a and b are going to pull out themselves, and we will be just differentiating e raised to x and e raised to minus x. But क्या मौका मिलेगा a b निकालने का, देखेंगे थोड़ी ही देर में. We differentiate for the first time. So we go dy by dx is equal to a बाजू में the constant move side में, and then e raised to x का derivative e raised to x, plus b खड़ा है, the constant stands by the side, and then e raised to minus x का derivative goes e raised to minus x into the derivative of minus x, which goes minus 1. Check please. Okay, ask yourself, if you are differentiating e raised to 3x, the answer is going to be e raised to 3x. It's going to ask you to apply the chain rule. No, you are going to take that as x. So first e raised to x के हिसाब से the e raised to 3x का derivative goes e raised to 3x, and having done that, we go into the derivative of what? Of what we have taken as x, 3x, and that's going to become 3 e raised to 3x. I hope that makes it very clear ऊपर का derivative. Now can I shift that minus sign over here? Now as I was saying, if you can see your first derivative has gone futile. माने कुछ ज़्यादा हुआ नहीं, माने you were not able to touch your a and b, but that is something what I knew from the very start. A and b are standing by the side of e raised to x, so I differentiate n number of times, which of course I am not allowed to do it. I am just allowed to differentiate two times, which I am going to do, go one more time over here. I will never be able to touch my a and b. So that's really worrying me right now. Okay, how am I going to eliminate? How am I going to eliminate my a and b? Because फॉर्मिंग डिफरेंशियल इक्वेशन का सेकंड मतलब है एलिमिनेट द आर्बिट्री कांस्टेंट्स ए एंड बी. So now at least we can try one more because we are allowed to differentiate two times. So differentiating once again with respect to x, that happens to go d square y by dx square equal to what? Again a सरक गया. A is a constant, so he'll just move out and e raised to x का derivative goes e raised to x. Similarly minus b side में हो गया and then e raised to minus x का derivative will be again e raised to minus x into the derivative of minus x minus 1. Check. It's a chain rule. It's calling for chain rule. When you want to differentiate e raised to minus x, you treated that as e raised to x. So the answer goes e raised to minus x into the derivative of what जिसको आपने x समझा था minus x, and that becomes minus 1. So finally I can see that minus, if we take it in the center, it's going to become plus. So as we had thought of, it happened exactly the same. You differentiated two times, none of the time you were able to touch your a and b because they are standing by the side of that functions which don't allow you to touch the a and b at all. You differentiate n number of times. So let's try one more. You cannot. You need to differentiate only that many times as many arbitrary constants are there in the solution. We had two, we differentiated two times. But now I think so AB ने अपनी मौत खुद चुन ली है. Now if you check that, you got back your y. No, you got back your y over here. So ऐसा बोलते हैं कि AB ने अपनी मौत खुद चुन ली थी. No, they eliminated by themselves. We bring in y over here by saying 1 and from 1. So I now see my differential equation is free of my arbitrary constants d of e. The magic what you saw happened because the powers were in your favor. No, they were same powers and opposite sign, and when you see such kind of thing, you just simply differentiate two times and उन लोग अपनी मौत खुद चुन लेंगे. You will come back to your same old y, and that's how you can eliminate your a and b. Can I repeat my last thing one more time? You saw that happening because the two powers, what you see, e raised to x, e raised to minus x, they are same size, opposite sign. So it really helps you. In the end, after differentiating two times, always you will find that the y has popped in once again, and then you can remove the arbitrary constants by bringing in your y, and that's how AB gets eliminated by themselves. Having said this, the immediate next question a thinking student thinks in this way: what if the powers are not symmetrical in nature? माने ये x और ये minus x या ये 2x and minus 2x now okay, they are of different size, then we have a problem. Then you are not going to see such kind of thing. Can I just put a small example to display that thing? Because unless and until I don't do that, you will not understand that thing. So let us make it quick. I am trying to go for थोड़ा सा non-symmetrical powers. माने let us say कि a raised to 2x है plus b raised to x है. Ready everybody? If I go for the same treatment what I did earlier, we are not going to see the y back. We are not going to get a chance to eliminate your a and b. Let's move quick. The dy by dx, you are allowed to differentiate two times to eliminate your a and b to come down to differential equation. We are trying that. The dy by dx is equal to a सरक गया and e raised to 2x का e raised to 2x into the derivative of 2x which is going to be 2. Check that. Plus b खड़ा है e raised to x का integration e raised to x. So finally can I pull that thing आगे 2. We are allowed to differentiate one more time. So d square y by dx square goes in this way. 2a खड़ा है, the constant stands by the side, and then e raised to 2x का derivative goes e raised to 2x into the derivative of 2x which is going to be 2, the chain rule, plus b खड़ा है and then e raised to x का integration e raised to x. Now finally I see this 2 gelling with आगे का 2 to become 4a e raised to 2x plus b e raised to x. Now this is something what we would not like to happen. Now you are not coming close to y, you are going away from the y. Now you have finished off your limited number of derivatives. Now you were allowed to differentiate 2 times, you finished off, and you were hoping कि ये वापस आएगा और y आ जाएगा like the previous sum. It didn't happen. So we are in a soup. माने हम अटक गया, हमारा arbitrary constant रह गया untouched. Never we were able to touch our arbitrary constants a and b. Neither they decided that they are going to kill themselves like the previous sum. So that's the problem. That's the problem. If the powers are similar, माने ये 2x है और ये minus 2x है, तो इधर तब तक 4 आ जाएगा. No, minus 2, so it's going to become plus 4, and you're going to pull out 4 and you're going to see that once again. So you can bring in your y. So that's what I'm trying to highlight. Okay, if the powers are symmetrical in nature and opposite in sign, that means it's e raised to 2x and it's e raised to minus 2x, you are going to surely see the magic happening in the end. A B अपनी मौत खुद चुन लेगे, the y will pop in once again over here. Thereby you will be able to eliminate your constants a and b. Sir, ठीक, accepted. But how we are going to deal with that? Now that's the next thing what we talk about. Task is what? When you want to form a differential equation, what is your task? You need to remove the arbitrary constants, of course by differentiating. So ask yourself, what's the best way to kill a arbitrary constant or kill any constant? No, make him stand alone. Because your a and b were standing by the side of functions who didn't allow you to touch your a and b, try to isolate the constants before you differentiate. Can I start now? No, this one, how to form differential equation of such kind of solutions, such kind of equations. No, they call it solution, and what we get is a differential equation. Let's target b first. No, let's try to isolate b. No, one very easy way to kill the constant, any बच्चा also after doing derivatives will say, constant को किसी function के साथ खड़ा रखेगा तो बच जाएगा. But if it stands alone, you can kill it. So now try to isolate, target your b first. You can select any one of it. I targeted b first. Let's remove e raised to x. Now, of course, not by rubbing. नहीं तो तू बोलेगा ठीक है सर निकाल दिया. No, I didn't say that. I didn't mean also that. We need to divide the entire equation by e raised to x, so that then the b stands alone, and that's allowed. You can divide the full equation by e raised to x. So e raised to x, e raised to x, and e raised to x. So finally I can see it's y e raised to minus x is equal to a e raised to x plus b. Sir, thoda sa यहाँ goof up हो गया. So this we agree, if it goes up you are going to make it e raised to minus x, but ये नहीं समझ में आया. That was pretty simple. Now that's your law of indices taught to you at 6th or 7th grade. It's a raised to m, a raised to n, it's a raised to m minus n. So you can see a raised to x. Now let's fire. We are allowed to differentiate 2 times, and if I go my differentiation for the first time, I killed my b. Check that, b standing alone, 0 ho jayega. So we start differentiating first time with respect to x, but that demands a product rule. So y into the derivative of e raised to minus x plus e raised to minus x into the derivative of y, please check that, is equal to, I hope you are comfortable, the product rule is equal to a e raised to x and the b is gone. Check, a sarak gaya and then e raised to x ka derivative e raised to x, b was alone, he got killed. We got the first success. We were successful in eliminating at least one constant over here. But right now, let's finish off that. E raised to minus x ka derivative, allow me to remove it from here only. E raised to minus x ka derivative will go e raised to minus x into the derivative of minus x, which is minus 1. Check. It goes e raised to minus x into the derivative of minus x, which is minus 1. Then probably what I can see is, I can just rearrange that thing as minus y e raised to minus x, and then I can pull e raised to minus x common. Can I stop over here? What's the reason of pulling e raised to minus? See, we know okay, we need to go one more time differentiation. We are allowed to differentiate 2 times, and we need to because a constant abib is in there. We need to eliminate our a also. But comma, when I go for differentiating one more time, I just saw okay, I will have to apply product rule here also and product rule here also. So why not take e raised to minus x common and apply only one time the product rule? As you can see right now, if I pull out e raised to minus x common and if I take in the bracket dy by dx the first term and followed by my minus y, these are few writing tricks which you happen to get into your rhythm by solving more sums. कि in the bracket try to put your plus का term आगे and the minus का term पीछे is equal to a raised to x. Please check. Can I remove for space? Now my target needs to be a, but if you differentiate now, no hastily out of excitement you may go for one more time differentiation right now. Remember, you will not be able to touch your a will survive. So apply the same method. Just like you isolated your B, it's time now you need to isolate your A because you are targeting your A. So my thing is we need to divide by e raised to x once again so that A stands alone and then we shoot, then we differentiate, then we fire. I hope it's very clear. Any viewer out there is going to understand this in a very easy way. Okay, before differentiating, isolate the constant, whichever you have targeted, and then you differentiate. And for the second constant, once again apply the same thing. Now isolate the constant before you want to fire for the second time. So we are over there right now. We need to make A stand alone before you differentiate, so that on differentiation A is going to get killed. So dividing once again to isolate bolega to I have to divide the full equation by e raised to x. So no, over here e raised to x and that's gone. I think you got it. The e raised to x has come down over there. Now once again I can apply my indices first of all. No, I am also in a hurry to differentiate one more time because ye mar jayega and I am going to taste my second success over here. But before that I just need to settle that. It's again I think so sounding what? A raised to m, A raised to n. It's going to go a raised to m minus n. So minus x pe minus x, it's going to become minus 2x. So now can I go for the second time? No, I will go over here differentiating one more time. Or can I raise it? Can I raise it? We are right now over here. And the method what we have used in a style over here, can I say in a style? Yes, it was a nice plan wherein to kill the constants. Constants were very smart. They were standing by the side of those functions which you were not able to touch in differentiating. So you just applied one simple method. Let's make the constant stand alone before we differentiate. You did that with B and now you did that with A before you are going for the second time. So now my last shot, differentiating once again with respect to x, it happens to go e raised to minus 2x, it's a product rule, into the derivative of dy by dx minus y and then plus dy by dx minus y into the derivative of e raised to minus 2x. Please check for yourself. I got my second success. The a has been killed. No differentiating both the sides with respect to x. The a is gone. But check this side. First function into derivative of second function plus second function into the derivative of first function. Check that. Now let's realize. It's going to be e raised to minus 2x. Please check it. Now when you go for derivative of that, the dy by dx ka derivative goes d square y by dx square minus dy by dx plus dy by dx minus y, it will be as it is, e raised to minus 2x ka derivative goes e raised to minus 2x into the derivative of minus 2x, which is going to be minus 2. Please check it. Now I see e raised to minus 2x throughout the equation, so I can cancel it. No, somebody says 2a plus 2b equal to 0, you need not break your heads to write a plus b equal to 0, it's like dividing throughout by 2. Similarly, I could see e raised to minus 2x in both the terms. So can we divide throughout by e raised to minus 2x so that even that's gone? Check please. It's very much similar to that. Now let's open the bracket. It's going to be d square y by dx square minus dy by dx. Now that needs to be multiplied over here. So it's going to be minus 2 dy by dx and that's going to become plus 2y is equal to 0. And finally, I can see minus dy by dx minus 2 dy by dx becoming minus 3 dy by dx. Now that's my differential equation which is free of arbitrary constants a and b, but we did it in style. Now we also got it, one very important thing over here. If the e raised to ka powers are same nature, same magnitude ka, but opposite sign, we need not go this kind of stuff. Just simply differentiate 2 times, it's going to come back, the y is going to come back once again, and thereby will be able to eliminate, or a and b will get eliminated automatically. You just differentiate 2 times. But when they go of different size, as in this case, I just removed that. If it goes of different size, the y was a e raised to 2x plus b raised to x. Now, ek jagah e raised to 2x tha, ek jagah e raised to x tha. In that kind of thing, you don't expect that the 2 times you differentiate, you are going to see back the y, where a and b gets eliminated by yourself. You need to use your basic concept. To kill the constant, which is the theme of forming a differential equation, make the constant stand alone. So, first I targeted b, I divided by e raised to x, I went for my first derivative, I killed my b. Now, before I went for the second derivative, my a was standing by the side of e raised to 2x, if I am not wrong, yes, or maybe a was standing by the side of e raised to x, let us put it in that way. And then before you differentiate one more time, you need to make your a stand alone. So, e raised to x ko niche leke aaya, I settled it, and then I fired my second time derivative, so that I could kill my e. Now, that is my differential equation. So, we say that is the required differential equation. I hope this must be quite satisfying. Let us move to the next one now. Now, coming to the third segment, as you can see, solve D using variable separation method. I have put in over here. No, solve D bolega, to now you are going, no, you were coming downwards, now you are going upward. From solution, you came down to differential equation by eliminating the arbitrary constants, by differentiating as many times as many arbitrary constants are there in the differential equation. We saw 2 sums on that. Now, given the differential equation, how we are going to reach back to the solution, the equation, which connects the 2 variables, no, x and y. I think so. Variable separation method is going to be used even in the next segment also, but probably what is variable separation method? One thing is for pretty sure, because your syllabus restricts itself to first order derivative, that means you must have differentiated only one time to reach to dy by dx. That means there must be only one arbitrary constant, and therefore to go back you just need to integrate one time. Let me keep it very simple. You must have differentiated only one time to reach to such kind of differential equation, because you can see only dy by dx. So, when you want to go back to the solution, the good news is you just need to integrate one time. So, that is your syllabus has restricted to that kind of sums. It talks only about first order no differential equation, order 1 dy by dx. Now, variable separation method ka matlab kya hai? Why do we need that? No, we have got dy by dx. So, what we need to do is, first of all we need to get dx on the floor. Mane dx upar aana chahiye. Then we try to push our x ka terms towards dx and then y ka terms towards dy. So, that when we integrate, finally the x ka terms will naturally get integrated with respect to x, because they are standing by the side of dx, and the y ka terms will get integrated with respect to y, because they are standing by the side of dy. Let me come in once again. You need to understand the method very nicely, because that is the method what we are going to use continuously till the homogeneous differential equation. Coming back, our differential equation contains what? Dy by dx, xk terms, yk terms. So, it becomes very natural that you need to push your xk terms towards dx, so that when you integrate those terms, that terms get integrated with respect to x. Similarly, your yk terms also need to be posted by the side of dy, or they need to be moved towards dy, so that when you integrate, finally the yk terms will automatically get integrated with respect to y, and that is why the name goes variable separation method. You cannot integrate xk terms with respect to y or yk terms with respect to x, and that is why the name goes variable separation method. Move your xk terms towards dx, move your yk terms towards dy. So, what I have been doing in my batches is, sabse pehle to try to reshuffle. Let us pick up an example. Try to reshuffle the terms and try to bring your dx on the floor, because when you integrate finally with respect to x, your dx is in the numerator, your dx is on the floor. So, in my words I happen to say get the dx on the floor. So, first of all, the first step I go y is equal to x dy by dx. The next I got a chance to push my dx on the floor. So, y dx is equal to x dy. So, at least dx dy are on the floors now, but there is a slight mismatch. The y needs to stand by the side of dy and the x needs to go towards dx. So, we push our dx down over here, and wahan se we push y down over here. Check that please. Now, I think we are comfortably positioned right now. We now can integrate both the sides, and it will go in the natural way. The x ka term will get integrated with respect to x, and the y ka term will get integrated with respect to y. But before that, I am extremely sorry. Before that, we need to punch over here the word variables are separated. no variables separated, and then final stage we integrate both the sides to reach to the solution, that goes log x. No, it dx तो आपका बाजू में है, we are looking at 1 upon x, on integration that becomes log x, we are looking at 1 upon y, that becomes log y, and then the constant c, I would prefer to write this constant also as log c so that I can get rid of my logs. I will show you how. But if all the integrations turn up to become log ka functions, then try to put your constant also as not c but log c, and then that will help you to get rid of your log. Check that how. Now log x is equal to, what I am seeing over here is log a plus log b. You can make it one log. No, log a plus log b, that becomes log ab, or log of ab becomes log a plus log b. So you can make that thing as log of cy, and then you can drop your log. No, don't cut it as I showed you over here, it doesn't get cut, but dropping the log we say the x is equal to cy. Now that's my solution to the given differential equation. I hope the example must have given you a very clear picture of variable separation method. Can I put my steps, and I would really enjoy showing you one more example in this. The steps are what? No, try to reshuffle the terms to bring your dy dx on the floor. Normally if the differential equation goes dy by dx, so dy was already on the floor. So your next step is, your next target in the next step should be what? How to get the dx on the floor. Once you get dy dx on the floor, the next step will be what? Move all the x ka terms towards dx and y ka terms towards dy. When it happens, you punch the word variables are separated, and then the last shot. Integrating, you had to integrate. No, when you want to reach back to the solution, no, to come down to differential equation, you go for derivative. To go back to solution, you need to integrate. So now once the variables have settled across the two sides, the x ka terms towards dx and the y ka terms towards dy, you just need to pull your last shot, integrating both the sides to reach to the solution. And if all of them go log, see to it you also keep your c as log c so that you can get rid of log, as you saw right now in this solution. So I would take a chance to show you one more sum under the heading of how to solve a given differential equation, or how to find the solution to a differential equation using variable separation method. And then student does happen to ask me one simple question, having done few sums in this in the regular batches. So what if the variables are not separated or cannot be separated? What do we do in that? We go for substitution. That will be the next heading. But coming back, let's see one more sum in this. Let's enjoy one more sum in this. Question is, find the solution to the given differential equation. The best part is your dy dx are already on the floor. माने dx भी ऊपर है, dy भी ऊपर है. Now can I do some pre-treatment before I start? No, the rules are what? Rules nahi, the steps are what? Get your dy dx on the floor. Thanks to the given differential equation, they are already on the floors. The next step is what? Try to push your x ka terms towards dx and the y ka terms towards dy. When it happens, you say the variables are separated, and then you integrate to get to your solution to the given differential equation. Solution means what? The relationship between the x and y along with that one arbitrary constant. Sir, how you are very sure of one arbitrary constant? Since the differential equation is of the order 1, no dy by dx. If I put that dx over here, it's dy by dx. That means you differentiated only once. That means the relation, the solution must be containing only one arbitrary constant. That is why we are supposed to integrate only one time to go back to the solution, and that's what your syllabus is restricting itself to. It works in our favor. Right now, can I pull my x common out here? 1 plus y square dx. Thanks to the differential equation, sir, why thanks? dx already floor पे है, so मेरे कुछ steps बच जाते. y 1 plus x square into dy. Check that. Now the misfitting terms. Now I would not like to see 1 plus y square by the side of dx, because I cannot integrate my y ka terms with respect to x, or the vice versa, the x ka terms with respect to y. So that term has to come over here and this term has to go down over there. So it goes x upon 1 plus x square dx, check, and y upon 1 plus y square dy. Now maybe the viewer out there is bit confused, कौन सा algebra से ये सब कर रहा है वो. It's very simple. I want to bring this by the side of dy, so I need to divide the full equation by 1 plus y square. When I did that, वहाँ से चला गया, इसके नीचे आ गया. Similarly, I didn't want 1 plus x square का term by the side of dy. I wanted it by the side of dx. So I need to pull it down. So divide once again by, we need not show that thing. It goes automatically. It's understood by the reader that that must have happened behind the screen. You need not show those steps. 1 plus x square वहाँ चाहिए था by the side of dx, and I hope the reason is very clear because x k terms need to be by the side of dx so that when integrated they get comfortably integrated with respect to x. Similarly, the y ka terms have to be by the side of dy so that on integration they get comfortably integrated with respect to y. 1 plus x square नीचे pull करने के लिए the simple algebra involved was what? Dividing the full equation by 1 plus x square. Check that. यहाँ से जाएगा, यहाँ नीचे आ जाएगा, सामने तो 0 है. It's going to take away all the things what comes down in the denominator below it. I hope that's very clear. Now coming back, I think the variables are now comfortably positioned. They are separated. So we punch over here, the variables are separated. The next step, check that please. Integrating both the sides. Integrating both the sides. Now that goes C. I hope you all must be knowing in integration, when you integrate a 0, which is a very rare case which never happened in integration, but by your definition of integration you are very comfortable to understand this. Derivative of a constant is 0. So when you integrate 0, which I did right now, it has to turn into a constant. Check. Derivative of constant is 0. So when you integrate 0, it has to give you back the constant. We integrated 0 on this side, so we got constant. Now how to deal with that? थोड़ा सा if you are good with your integration, integration बहुत ज़्यादा heavy नहीं है differential equation में. Even that goes, that is why I always keep saying just the fifth topic. If you are comfortable with that, only the basic integrations are then used in the forthcoming topics, as in like derivatives maybe. Once you come into application, if you check all the 5 applications, derivative was hardly any challenging derivative over there. Basic derivatives, x cube, x square, 1 upon x, वो सब था. Similarly over here also, the integrations required are 2 basic. अब viewer out there बोलेगा basic है फिर भी हमें तो याद नहीं आ रहा है. क्यों याद नहीं आ रहा है? Now if you just put one small 2 over here, multiplying throughout by 2. Now that adjusted to f dash x up, oh gosh, वहाँ बोला हाँ यार, that is now f dash x upon fx, it's log fx. It's f dash y upon fy, it's log fy. Or maybe I punch the same formula. Why should I sing the formula in different variable? It's once again f dash x upon fx, it's log fx. Sir, ये समझ में आया now that 2. But you multiplied by 2, वो भी समझ में आया. लेकिन in our normal course, we happen to adjust 2 and half. अगर ये half और half आप बाहर रखोगे, that 2 later on you are going to pull it on the other side. So why not in differential equation when you want to adjust 2? Let the entire equation get multiplied by 2. Why to go for that half over there? You can use that also, but I am pretty sure in the end that half you are going to pull it on the other side. So I did a smart move at the beginning only. Rather going 2 and half, I went 2, 2, 2. Check that. Now that becomes log of 1 plus x square. Can I punch in one more time? How? It was f dash x upon fx. Same way, even that's f dash x upon fx, which becomes log fx plus c. So log 1 plus y square. And then I would like this constant ka side then should be adjusted to log c. Check please. It needs to be. The reason that 2 terms went log, so I would like to keep my constant and constant also in terms of log so that I can get rid of log. How? That's log a, but I hope I need to just punch in one more time. क्या हुआ इसमें? First of all, just figure out the steps. आपने x common ले लिया. The good point of the differential equation given to you was what? Thus the dx was on the floor. Nice. Pull out your x, pull out of here. Now what's disturbing? Sir 1 plus y square यहाँ होना चाहिए था. ले लो, divide. Sir 1 plus x square वहाँ होना चाहिए था. Divide. Got to that. Now you just put in your 2 throughout the equation, it gets adjusted. All of them get adjusted to what? F dash x upon fx, f dash x upon fx, log fx plus c. And then because both the terms have gone log, we need to adjust the constant even to log c so that we can get rid of log. How? Now that's log a plus log b. You can club it into log of ab by the rules of log. So log of 1 plus x square into 1 plus y square. Please check that. The log AB, that was log A plus log B, and that's equal to log C. So I think we can now drop log. That was the reason why the C was readjusted to log C. Get that. Now that's my general solution, or you can say solution. Now why did I say general solution? I'll tell you. एक further इसमें question दिया है. the x is 2 and the y is 0. Check it. Put x 2 and y 0 and find the particular solution. Find the particular solution ka matlab hai you need to know the C ka value, put it back over here, and then that solution will be then called as a particular solution. Let me throw some light on that. Can I take some space over here? Y equal to ax plus b is a general line. You cannot draw this line. I hope that sounds y equal to mx plus c. So, it is a line ka equation. Now, that is a particular line, y equal to 2x plus 3. Now, that is particular line, that is the general line. How do you say particular line? Because sir AB ka value malum hai. Now, I can draw this line, it is a specific line. Similarly, over here also. They are supporting you with some x and y ka value which will help you to get the C ka value. You put back your C ka value over here and then that general solution will then be called as a particular solution. So, right now in the sum they are giving me the x is 2 and the y is 0. So, that goes 5, that goes 1 and the C turns out to be equal to 5. Check please. No, when you put 2 over here that goes 5, when you put 0 over here that goes 1. So, 5 into 1 the C ka value has turned out 5. Now, that C ka value मैं normally हमारे बैच में ऐसे बोलता हूँ जेब में डाल के डांस करोगे. Now, put it back over here and that solution will now be called as a particular solution. So, your sum will contain two solutions, the general solution, block it, and the particular solution wherein you found the C ka value and put back the C ka value back into the general solution to call that general solution now as a particular solution. I hope I am not going blah blah blah. Variable separation method has been nicely justified. At this critical point, a batch does happen to ask me, of course in the batch we happen to solve around 8 to 9 sums to make it very but even you must have done at your places also. But this is last minute revision, so I cannot afford to bring in more sums over here. But the picture now has become very clear. dy dx on the floor, get your x ka terms towards dx, get your y ka terms towards dy, punch the word, variables are separated. Now integrating both the sides, get to the solution. The x ka terms will get integrated with respect to x, the y ka terms will get integrated with respect to y, and then you are going to land up to the solution, the start point. I hope this is very clear. Now, the batch happens to ask me, sir, what if we are not able to separate the variables? Let's take a sum on that. So, now as per my batches, they happen to ask me, as I was telling you just few moments ago, okay sir, what if the variables are not separable? As in right now you can see that the very first step is what? Try to get your dy dx on the floor. Now, dy is already on the floor. Out of excitement, if you push your dx over here, which I think so it's a natural step. Now, if you push your dx over here, you got it, the y gets locked in that. Now, you can't pull your y down. No, whenever this is going to go down, it's going to go the full bracket. So, your y has got locked with dx. Now, over here it is very clear by visual inspection that your x and y variables cannot be separated. You cannot put your y ka terms by dy, by the side of dy, and x ka terms by the side of dx. In that case, we happen to do what? Can I just get it to the base wapas se where we were? Dy by dx. Now, what we cannot separate is your 4x plus y plus 1. So, they say substitute. No, go for substitution. They say put 4x plus y plus 1 is equal to u. Now, when I proceed again, before that I would like to make one rough picture of this. Now, once you put substitution something as u, what is that something? What you cannot separate? Yes, of course, I should have gone 4x plus y as u, but I thought कि 4x plus y तक जा रहा हूँ u बनाने को तो पूरा ही u कर देते हैं. That will have my integration more simple. That will be keeping my integration more simple. But now, once you put u, something as u, your forthcoming new differential equation or the new looks of the differential equation will now be containing du by dx, u ka terms, x ka terms. That should be the picture in a mind of a student. When you put something as, your presently the differential equation by normal standards contain what? Dy by dx, x ka terms, y ka terms. Yes sir, you just gave us few examples, few sums wherein this was very clear. The differential equation does happen to contain what we are solving in the heading of 3. It contains dy by dx, the first order derivative, x ka terms, y ka terms, and then we try to get dy dx on the floor and the entire process, variable separation method. After substitution, the differential equation takes this new shape. The differential equation now contains du by dx, u ka terms, x ka terms. Can I help you? Now check. we differentiate with respect to x before going over there, because I need to bring in my du by dx, because once it's u over there, no, it's logical, it's pure logical. Once you are putting something as u in that, so you badly need that du, because u ka terms will then be integrated with respect to no u, so you need that du. So we go for du by dx, we differentiate with respect to x, so that's going to be 4 1, y ka derivative dy by dx, I hope everybody must be knowing that, 1 ho gaya 0, and the du goes du by dx. It was differentiating with respect to x. So if you go from left to right, sorry, right to left, it's du by dx equal to 4 into 1 plus dy by dx, check that. And therefore I can see very well clear over here the dy by dx is going to change to what? Du by dx minus 4. Now that patch of mine, no, this patch, I need to stick it over here, and what you are going to see is what? A new differential equation formed which contains du by dx, u ka terms, x ka terms. The old one was containing dy by dx, u ka terms, x ka terms, what you can see right now. The new one coming in, dy by dx will be replaced by du by dx minus 4, check that. And the samne ka thing you have put as u. Now from here on, play your same old method, variable separation method. Try to get your du dx on the floor, then push your u ka terms towards du, push your x ka terms towards dx, punch variables are separated, and then integrate both the sides. U ka terms will get integrated with respect to u, the x ka terms will get integrated with respect to x. Get your solution, it will be u and x. Aapka solution will come in terms of u and x. Don't forget to resubstitute, to come back to the old variable. Let's check that. Minus 4 मैं यहाँ ले लेता हूँ plus 4, check. dx on the floor, dx comes on the floor. Now u plus 4 I think so needs to be posted over there. No, u ka terms need to go by the side of du. So it goes du upon u plus 4 equal to dx. Now I think we are well positioned, we can punch in the word, variables are separated, and then integrating on both the sides. So integrating on both the sides, now that goes log u plus 4. You are right now thinking, hai, log u plus 4 kaisa? Du hata ke I can see 1 upon u plus 4. 1 upon u plus 4 needs to be treated as 1 upon u. Sir, are you very sure? I have been saying that this in my chapter 5 ka LMR continuously. Your u can always be replaced by some other linear form of u. The formula applied is still the same. U or u plus 4 ka jati same hi hai. Even that's linear, even this is linear. So right now I am reading 1 upon u plus 4, but I will be giving it a treatment of 1 upon u, which happens to be on integration becoming log u. So that becomes log of u plus 4. Check please. And then samne I have got 1 ka integration, which everybody must be comfortable, x plus c. Sir, is बार आपने log c नहीं किया. All my terms go log. Then I adjust my constant to log c to drop my log. Now x was not containing log, so I keep my c also as c. And then please do not forget in the end to resubstitute u, तो हमने हमारी मदद के लिए use किया था. The u was actually 4x plus y plus 1 plus 4, that becomes y. Check, you got how 5. No, the u was 4x plus y plus 1, check, and plus 4 after that. So plus 5 equal to x plus c. Now that's my solution. That's my general solution to the given differential equation. I hope this example must have made it very clear, but let me square it off properly. Once you decide you are not able to separate the terms, whatever you are not able to separate, you need to put it as u. Now once you decide to make it u, the new picture has to be very clear in your mind so that you can go accordingly by that. The new differential equation after substitution is going to contain du by dx, u and x ka terms. So bring in your du by dx in the picture. How? By differentiating with respect to x. You saw that the dy by dx will now change to what? Du by dx minus 4. Push this entire block over there. Now that gets changed to u as per your substitution. The dy by dx becomes du by dx minus 4, and then start playing your normal game. Let me come in once again, du by dx minus 4 in place of your dy by dx, and that was by substitution u. Now from here on, you go by a normal method, variable separation method. Try to get your dx on the floor. So du dx on the floor, du is already on the floor. So dx on the floor. How? First push your 4 on other side, done sir. And then get your dx on the floor, done sir. Now mismatch. The u plus 4 should be standing by the side of du. So push your u plus 4 down, dx ke saath 1 khadda hai. We say the variables are separated, and then we punch in integration to reach to the solution. Do not forget in the end to resubstitute your u back as whatever you substituted as u. So coming back into the next segment 4, give me a moment to clean up the screen to talk about the homogeneous differential equation. This was about substitution. How do you play in differential equations where the variables are not separated? What you cannot separate, go for u. The new differential equation now will be shaped up into what? Du by dx, u ka terms, x ka terms. Then follow the same old process, old procedure, your variable separation method. With that, we enter into the segment 4 now. Coming to the fourth segment, homogeneous differential equation. Now what you see over here is a homogeneous differential equation. सवाल वही है, solve and find the solution. Now first and foremost the question is, sir, how we are going to identify that it's a homogeneous differential equation. Now check that. All the terms ka net power should be the same. As in if you see x, y, each has got no power 1, 1. So the total power goes 2. यहाँ का भी the total power is 2, 2y square का भी power is 2. So each and every term का net power, the total power has to be same for all the terms. Now that says the differential equation given to us, which contains dy by dx, x and y का terms, it's a homogeneous differential equation. Now my only point what I want to tell you is, इसमें y upon x छुपा है. So try to flash up the y upon x and then follow your substitution. No, that's something what's inseparable. So we put y upon x as u and then we know the standard procedure. We need to come down to du by dx, u ka terms, x ka terms. We play variable separation method. We are seeing this example. But first, the viewer out there should have a very clear frame. How am I going to identify in the sum? See, they don't happen to say, they just happen to say solve the given d. बाजू में 4 मार्क देख के मैं तो d आ जाता है, solve d. So there are no 2-3 types. So no, identification becomes more important. Now over here it was very quick on that. Homogeneous का differential equation का identification goes very simple in a student. सर ने बोला था total power. मैंने अकेले ने नहीं, सब सर ने बोला होगा. The total power of each and every term should be the same. Total power over there 1 plus 1 2, over here 2, over here 2. It's homogeneous. Then I just gave you one small hint. इसके अंदर y upon x छुपा है. Flash it up. You see that, go for substitution. So what? Y upon x, u. And then no, change your differential equation to have a new look of du by dx, u and x, and then follow the standard procedure, variable separation method. Allow me to do it over here. Now, सबसे पहले I bring मेरा target है, I want to see my y upon x. No, if I am going to put my y upon, the best part about homogeneous differential equation is what? All the time सामने का side, the dy by dx, come to dy by dx, the सामने का side will surely contain y upon x if it is a homogeneous differential equation, which I am going to show you right now. And then once you see that, the standard substitution for all the sums under the heading of homogeneous differential equation goes y upon x, we need to put u. Because all the time सामने की तरफ you will be having y upon x. So the only option left for you for substitution will be what? Y upon x equal to u. So it becomes a very easy segment for a student once he has a good hand on it. Because ज़्यादा variation नहीं. Because he knows कि if it's a homogeneous differential equation, उसमें y upon x से the substitution all the time will be what? Y upon x equal to u. So let's do that. Where x, y, I bring it down, I bring it over here, I bring it over here. Check. Now I cut my 1x. I hope that's very clear. Now I cut my 1y. As I was telling you, y upon x छुपा है. तू बोलेगा सर मुड़ के देख लो, y upon x भी x upon y भी है. Now that x upon y we can always treat it as y upon x. सर जी काका का राज x upon y को हम y upon x बोल देंगे. नहीं मैं ऐसा कुछ नहीं बोला. You can reciprocate. You can write that thing as 1 upon y upon x. 1 upon y upon x. And so I can see the entire right hand side now filled with y upon x. So why should we wait for it now? Let the y upon x go u, the substitution, and now you should be in a very comfortable position to understand that once you put u, what you are heading for. The new differential equation ka looks will be having du by dx, the u ka terms, the x ka terms, and then the standard procedure of variable separation method. Let's get for that. The y is equal to ux. तू बोलेगा सर जी क्यों आपने x को वहाँ लिया? No, when I differentiate over here now, the dy by dx will change to what? I'll get it directly. Over there, I'll have to apply quotient rule. Over here, I have to apply a product rule. Any student out there will say, sir ji, product rule अच्छा है. Second bigger advantage, straight away when you differentiate with respect to x, you get dy by dx will be changed to what? Directly over there. Check. u product rule, u into the derivative of x plus x into the derivative of u. I don't think I need to punch it hard. U into the derivative of x, that goes 1, plus x into the derivative of u, that goes du by dx. So now let's put the block over there. dy by dx changes to u plus x du by dx. I am sorry, I am objecting, I am hindering your screen ka thoda sa part, check that. Coming to next, that's 1 upon u. Sure, we are shocked. How 1 upon u? No, shocked क्यों है? The x upon y is basically 1 upon y upon x, or maybe you can go by simple algebra. The y upon x is u, so x upon y has to be 1 upon u plus the 2u. Now mera game starts. My only thing is when I'll get my dx on the floor. So start moving your terms. From here on, it turns out to be a very simple, moving the terms. You shift your u on this side, done sir. 2u minus u leaves you with u, agreed sir. Cross multiply 1 plus u square the whole upon u, done sir. You got a chance to put your dx on the floor, thank you sir. Your x comes down by the side of dx, got it sir. The u and 1 plus u square goes on the side of du, done sir. You can punch, variables are separated sir, very comfortable, got it. And then a small adjustment of 2, not half please, 2. I hope you got it. हाफ वहाँ रखता भी तो एंड में वो 2 आप वहाँ पे ही ले लेते, तो पहले ही रख दो. सो डी में थोड़ा सा एडजस्टमेंट में यू नीड टू बी मोर अलर्ट. नाउ कमिंग बैक, आई थिंक सो यू गॉट इट. मैंने 2 क्यों डाला था? नहीं, मैंने टाइम पास के लिए 2 नहीं डाला. इट्स नाउ एफ डैश एक्स अपॉन एफ एक्स. नो, परफेक्ट डेरिवेटिव 1 प्लस यू स्क्वायर का. इट्स एफ डैश एक्स अपॉन एफ एक्स. दैट्स नो, आई वुड लाइक टू गो वंस अगेन till before putting my last concluding steps over here. Let's come back. Sir, if it is homogeneous differential equation, we got it. Okay, once we come to dy by dx by pushing that x upon xy on the other side, and similar treatment in all other sums. No, you come to dy by dx, and I am pretty sure if you come to dy by dx, the samne ka side, if it is a homogeneous differential equation, in all the sums, you are going to see y upon x flashing up. Y upon x, x upon y. Both I treat it as y upon x. So straight I go by the side, I finish off my substitution ka procedure. What substitution? The y upon x together. You put that thing as u. Now I prefer to write y equal to ux for 2 advantages. That demands product rule. That's easy. And when I go for differentiating with respect to x, straight away the dy by dx will change to what? In my new differential equation, I got it directly. Check over there. Now I am pulling it over here. U plus x du by dx. Check it. If the y upon x is u, then x upon y is 1 upon u. Easy for any SY student. Plus 2u. Now, first of all, you check it. The new differential equation, what you are now seeing, the new looks of the differential equation after substitution, now contains du by dx, u ka terms, x ka terms. So now start your normal procedure. Now check the time when you can get the dx on the floor, at least not now. Now you need to start moving your terms. U comes over here, subtract. 2u minus u leaves you with what? U. Done sir. Cross multiply 1 plus u square the whole upon u. Yes sir. We got a chance to pull dx on the floor, do it immediately. Done. Bring your x ka term by the side of dx, got it sir. Move your u ka terms towards du, doing it sir. Check. U up 1 plus u squared. Wow. Variables are separated, we punch in integrating both the side, we are comfortable sir. A small adjustment of 2 to make it f dash x upon fx, so 2, check. And then that's log of fx, log of 1 plus u square, and that's equal to 2 log x. Please check. If it is log x, then I would like to keep my constant also adjusted to log c. All the terms go log, you get a very good chance to drop the log. Now next what? I pull my power up. Check. I pull my power up. Now the power goes up. Power falls down, the power goes up. Now that gives me a chance of log a plus log b to make it as log ab. No, log ab. Check. That gives me a chance to drop the log. You saw that very clearly. Drop the log, and don't forget in the end to resubstitute your u back to y upon x. So it was u square, it goes y square upon x square. Can I settle it down? X square plus y square. Can we come into the last paragraph one more time? Check. After adjusting the 2, that was perfect f dash x upon fx. You finished off the integration one shot log of fx plus c. And then over here 2 by formula 1 upon x ka integration goes log x. and then we adjusted our constant to log c, because if all the terms go log, we would like to keep our c also as log c, so that we can drop log. Now how? Power up, you got a chance of log a plus log b becoming log ab, becoming log ab, check. You got a chance now to drop the log, done sir. Now don't forget the last step, change your u back to, resubstitute your u back to y upon x, so u square goes y square upon x square. Let's settle down, it's going to be x square plus y square the whole upon x square. I push it on the other side, it gets cx raised to 4. No, it was x square multiplied by one more x square. So that's my general solution to the given differential equation. Can I now finish off the conclusion of that? The moment I see homogeneous differential equation, tell me how we are going to identify the given differential equation in the question paper which says solve. It's a homogeneous differential equation. So the powers, the power of x, y, the total powers in each and every term is going to be the same. Sorry, somebody just flashed light, so you must have observed that ek light ka shadow aa gaya. But coming back, can I just narrate the steps? How a student is going to identify that it's a homogeneous differential equation? So we got it. The total power of each and every term has to be the same. As in our case, it was 2, 2, 2 in the initial question mark, question mein. And then once it is homogeneous differential equation, so then it's a very simple thing. Somehow we need to reach to dy by dx, we pushed our xy down. In different sums, different treatment. But come to dy by dx, and I am pretty sure looking at all the sums in the state board textbook, you happen to see y upon x. Y upon x, x upon y. I saw y upon x. So we go for substitution, y upon x u. Follow the procedure and then come back into the differential equation to put your entire substitution ka block in that, and you are going to see the new form containing du by dx, u ka terms, x ka terms. Follow your variable separation method. Start moving terms, get a chance to put your dx on the floor, move your x ka terms towards dx, move your u ka terms towards du. Variables are separated, integrate, get the solution, but that's u and x. You need to find your solution in x and y. The original variables were x and y. So then resubstitute to reach to the original solution of the given differential equation. So with that, I think with the sum you were very comfortable how to deal with the homogeneous differential equation. Just remember one thing, homogeneous differential equation contains y upon x. The standard substitution, put it back, play your normal game, variable separation method. Coming to the next segment now. Now honestly speaking, differential equation ka this is the first year. It was there 2-3 syllabuses ke pehle when science and commerce used to run parallel the portion, the syllabus. But once they had decided that commerce will go its own way of selecting the topics for the syllabus of SYJC, differential equation was skipped for a very long time. As far as my memory goes, for 4 syllabuses, that means around 15-18 years tak, differential equation was not there. And now they have brought in differential equation, and in this year students को थोड़ा सा वो step 5 आपका fragment 5, segment 5, fragment 5, linear differential equation, it's a step oriented game. So as far as I understood, it should not have been a problem, as in like homogeneous differential equation. Once you have identified its homogeneous differential equation, you know, come to dy by dx, you will be seeing on the right hand side all the y upon x spread about, and then you have to go for standard substitution. So that was a strict procedure. So student enjoy that kind of procedure. So similarly in linear differential equation, I have a feeling that it's a step oriented thing. And I am going to do something over here. No, I am going to put down the steps over here, and parallel will work out a sum. No, a step and the sum mein wo step, and I think that should make you really very comfortable as far as linear differential equation happens to go. And then you should wish sorry कि ऐसा एक sum आना चाहिए. Step oriented है, तो if I know the steps, I am comfortable with the sum. I just need to apply the steps. Let's see one sum on linear differential equation. Now first and foremost, a linear differential equation looks like what? Because there they will not turn up saying ke solve the given linear differential equation. They just say solve. They put up a differential equation. You by yourself have to identify ke ye normal hai, homogeneous differential equation hai ke linear differential equation. So that becomes a task for a student. So the first step is the identification of a linear differential equation. So we say it is of the form dy by dx plus py equal to q, where p and q are either functions of x or they are constants. So check that. Any differential equation which looks like this, first of all you need to have a very clear image of this. The dy by dx plus py equal to q, where p and q needs to be what? Where p and q needs to be either constants or they can be function of x. Then that is a linear differential equation. Then you need to follow the steps of linear differential equation in that sum. So my sum goes in this way. The dy by dx, I said I will be putting the steps, I will be working out the steps in my sum. So that will be a perfect combination for any viewer out there to understand how to deal with the linear differential equation. But the very first task was how to identify the question में differential equation जो दिया था, what they are giving me is a linear differential equation, because only after I decide I will be working out the steps on that. So dy by dx plus y is equal to e raised to minus x. Now I can see it's a perfect sound of that. The dy by dx plus py equal to q, where p goes 1 in that, check please, and the q goes e raised to minus x, and they did happen to say the p q are either constants, as in that case the p is constant and the q can be function of x. The p q can be constants or they can be functions of x. So you can see the q is a function of x. So it's decided it's a linear differential equation. Let's go slow. Let's put a break. Linear differential equation का look क्या है? Sir, dy by dx plus py equal to q. Is that? Yes sir. Is dy by dx plus py equal to q, where p and q need to be either constants or functions of x. My p is 1, constant, okay, allowed, and q is e raised to minus x, it's function of x, even that's allowed. My p q needs to be functions of x or they can be constants. Done. Having done that, in the second step you need to find something called as integrating factor. We write if. If is allowed, a short notation. We find something called as integrating factor by e raised to integrate p dx. Now integrating factor is e raised to integrate p dx. So over here in the second step I find integrating factor e raised to integrate 1 dx. Check. Saji, you said e raised to integrate p dx. My p is 1 in my no given question right now. So it goes e raised to x. Check. Can I repeat? In the second step you need to find integrating factor, something called as integrating factor, that is found by e raised to integrate p dx. In my sum it goes e raised to integrate 1 dx. You got e raised to x. Third step में you multiply your entire differential equation, you multiply the differential equation by the integrating factor. So in my this sum I need to multiply my entire differential equation with the integrating factor e raised to x. I am on e raised to x dy by dx plus y e raised to x is equal to 1. Now maybe viewer out there thoda sa confused, इधर 1 कैसे हो गया? The moment you multiply this with e raised to x, no, that's 1 upon e raised to x, and when you multiply with e raised to x, that goes no 1. You got it. Now fourth step, the left hand side, after multiplying the differential with differential equation by your integrating factor, the left hand side will automatically get adjusted to the derivative of y into integrating factor. Hold back, I am showing parallel. The left hand side gets adjusted to what? The derivative of y into integrating factor, y into integrating factor. Is that the case which has happened over here? Is the left hand side got adjusted? Did the left hand side get adjusted to derivative of y into the integrating factor e raised to x? Check for yourself. Check the derivative of that. Y into the derivative of e raised to x, that, plus e raised to x into the derivative of y, that. The left hand side did got adjusted to the derivative of y into the integrating factor, which in my sum was e raised to x. And now last step, we know to reach to the solution we always in the last step have to go for integration. So fifth step, integrate to reach the solution, integrate to reach the solution. Now this is worth watching over here. Since the left hand side has got adjusted to the derivative of y into the integrating factor, when you integrate both the sides, of course with respect to x, the left hand side you will be left with only y e raised to x. सामने का भी बाकी है, but this doesn't go down well in the batch. अचानक से people start screaming, oh gosh, when you integrate this side you are left with y raised to x. I just want to punch the definition. When you integrate derivative of any function, you are left with the function. check that line. We need to narrate, we need to rehearse the steps. That's the meaning of last minute revision. I am not going to bring in one or two more sums. Let's get used to the steps, and the two more sums you can always refer the LMR sheets wherein I have provided two more sums under this heading for your good reference. But a student is comfortable only if he understands this 5 steps and its application in a related sum, which is of course which needs to be a linear differential equation, which was the case in my example right now. But first of all, coming to the line, when I integrated both the side, यहाँ पे on this side when I integrated, I am left with only y raised to x. Now that was the benefit of getting derivative of y into e raised to x. Now when you integrate a derivative of any function, you are left with the function. Check. Can I take some space over here? Okay. When you integrate a derivative of log x, check that please, with respect to x. That means you are integrating 1 upon x with respect to x. You get back what? Log x. That's what I said. When you integrate derivative of any function, you are left with that function. Check for yourself. When you integrate derivative of any function, you get back the function itself. So when you are going to integrate the derivative of y raised to x, you are left with y raised to x, as if the derivative and the integration, they cancel out with each other. And that what integration means. Integration is anti-derivative, or derivative is anti-integration. They cut out each other and you are left with the function. But I think so that was a better example. If you want to understand one more time, किस बात पे हम लोग चर्चा कर रहे हैं? When you integrate derivative of any function, you are left with the function. So over here, when I am integrating derivative of log x, that means I am integrating 1 upon x with respect to x, which is going to get me back to log x. That's what I said. When you integrate derivative of any function, you are left with that function. So when you integrate that function, you will be left with, when you integrate the derivative of that function, you will be left with that function. So that's the advantage of linear differential equation. Left hand side का integration का tension ही नहीं है, because it's a perfect derivative. So when you integrate, you are going to be left with the function whose derivative it was, and सामने 1 का integration x, and then of course the constant c. Now I got my solution so easily. But I do understand out there, everybody wants to see this one more time from my mouth. Sir, आप बोलोगे अच्छा लगता है, rather we reading the steps. So can I just project the solution one more time for you all, and then at the same time we also get a chance to rehearse the steps also. We can spend a minute or two back into that. Now first of all, let's rehearse the steps, then we'll we go for the solution. The dy by dx, any linear differential equation happens to look like what? Dy by dx plus py equal to q, where p and q need to be what? Either constants or they need to be function of x. Second, once decided it's a linear differential equation, the second step you need to find the integrating factor. How? E raised to integrate p dx. Once you found the integrating factor, multiply the entire differential equation by that integrating factor, and you will find what? The left hand side will automatically get adjusted to the derivative of y into integrating factor. And once that is done, you just need to integrate. The last step, you need to integrate to reach to the solution. And because your left hand side was a derivative of y into integrating factor, when you integrate that side, you are left with only y into integrating factor. When you integrate derivative of any function, you are left with that function. Can I come in one more time? I need to. Steps need to go deep down in you. If you are thoda sa uncomfortable with the steps, I don't think so anybody would prefer to solve any linear DE ka sum, which happens to be so simple out there. And I personally always feel all these sums, solve DE to reach to the solution, they are of weightage 4 marks. So it's easy to grab. So why not? Just it was a matter of few steps. Let's do it one more time. The linear differential equation looks like what? The very first question that pops in the mind of a student when he happens to see a question over there. कि क्या ये D linear differential equation है? Any differential equation of the type dy by dx plus py equal to q plus py equal to q, where p and q need to be strictly what? Either constants or functions of x. It is then a linear differential equation. Second step, you need to find the integrating factor. E raised to integrate p dx. You found integrating factor. Third step, multiply. अभी ढूंढा क्यों? जेब में डाल के डांस करेंगे? So ऐसा याद रख सकते हैं. Third step, multiply the entire differential equation by that integrating factor. Once you do that, you are going to find that the left hand side has got adjusted to, now this is something you need to remember, the left hand side, in which you are going to observe also. The left hand side has got adjusted to the derivative of y into integrating factor. I repeat, after multiplying the differential equation with your integrating factor, the left hand side of the differential equation gets adjusted to the derivative of y into integrating factor, and then your last step, integrate to reach to the solution, and that's the beauty of that step. When you integrate derivative of any function, you are going to see the function directly without you taking any efforts of integration on that side, which was the case in our differential equation. After multiplying with the integrating factor, the left hand side became derivative of y into integrating factor. So when you integrate that side for the last step to reach to the solution, you are just left on that side with y into integrating factor, because when you integrate derivative of any function, you are left with that function. You were integrating derivative of y into integrating factor, you are left with y into integrating factor on that side. सामने का integration थोड़ा सा you will have to take efforts, which in this case was minimum. One का integration was x, and of course the plus c over there. That made you reach comfortably to the general solution. Now can we just look into the steps? Once again, not the rehearsal, the application part. My differential equation ka sum, what I gave you over here, my linear differential equation ka sum was this way: dy by dx plus y equal to e raised to minus x. It actually sounded very clearly over here. It was dy by dx plus py equal to q, where the p goes 1 and the q goes, I do happen to write all this because I need to verify my p and q need to be constants or they need to be functions of x, which is right now the case. Okay. Having done that, second step, I need to find the integrating factor. How? By e raised to integrate p dx, which is 1 dx. The integrating factor you find by what? E raised to integrate p dx. E raised to integrate 1 dx in this sum, which turns out to be e raised to x. इसको जेब में डाल के डांस करेंगे? No. Sir, we multiply the entire differential equation with this integrating factor. This integrating factor multiplying over here. So e raised to x dy by dx, please check it, plus y e raised to x is equal to 1. I hope you all got 1 case. That's 1 upon e raised to x. When you multiply with your integrating factor e raised to x, you get the cut, you are left with 1. Now having done that, once you multiply the differential equation with your integrating factor, the left hand side will surely get adjusted to what? Derivative of y into integrating factor. Y into integrating factor of my sum is e raised to x. Of course, सामने ये 1 है. The left hand side has got adjusted to the derivative of y into the integrating factor. But you can check. If you take the derivative by product rule, it's e raised to y into the derivative of e raised to x, you got that. And then plus e raised to x into the derivative of y, you got that. So left hand side has got adjusted to the derivative of y into integrating factor, which is a step in your linear differential equation. It is going to happen all the time if your integrating factor is correct. Having done that, the last step, integrate to reach to the solution. So when I integrate both the sides with respect to x, this side I am left with only y e raised to x. Check. Can I punch that line last time for one more time? Wow. When you integrate the derivative of any function, you are left with that function. You understood very well with that log x ka example. So you are left with y raised to x on this side, and सामने integrating 1 will give you x plus the constant c. That's my general solution. You all must have appreciated this segment of mine of linear differential equation, how beautifully he has put down the steps, and equivalently at the same time he did apply it in the sum 2 times to show us, and he also made us rehearse that thing. Before we leave, quick rehearsal. Dy by dx plus py equal to q, tick mark. It's a linear differential equation. Next step, find integrating factor. How? E raised to integrate p dx. अब जेब में डाल के डांस करेंगे? No, not at all sir. सम में डाल के डांस करेंगे. Wow. Multiply the differential equation with your integrating factor. The left hand side will get adjusted to the derivative of y into integrating factor. Now just integrate to get to your answer. Because your left hand side has adjusted to derivative of y into integrating factor, when you integrate that side, you are just left with the function y into integrating factor. सामने का integration थोड़ा सा you have to take the effort. In this case, it was minimum. 1 का integration x plus the constant takes you comfortably to the solution. So now give me a chance to get into the last one, application of d, but I will have to remove all these things because I need to project a question over there. Question is a paragraph format, so I need to put that question over there. Then we can talk on that one sum of application of differential equation. LMR mein I can afford only one sum. I hope you all understand. Let's look into the last segment now. So finally we all have come down to the last segment of the last topic, application of D, and I would really like to explain that using this example. It's a wonderful one. Now before I start, I would just just go through the question. It says the bacteria increases at the rate proportional to the number of bacteria present at that time. Now I think it's biology. Mane tray mein if you have got, let us say, no bacteria, no, they will intermingle amongst themselves. Please don't take me in the wrong way, and they are going to increase as per that thing. So it all depends upon the number of bacteria present at that time. What depends on the rate at which the bacteria is increasing. It's proportional to the number of bacteria present in the tray at that given time. And then a few things they have given us. Original number n doubles in 3 hours. In how many hours the number of bacteria will become 4n. Now सबसे पहले तो I need to define few variables over here. There are two variables involved in this. The number of bacteria present and the time t. So can I say let x be the number of bacteria present at any given point of time t, bacteria present at any time t in hours. So no variables are defined. Now I hope as a simple student also, school going student also, he or she would understand that we need to bring out a relationship between the x and t to find out how many bacteria are present at any given point of time t, or what will be the time t when you have got this much of bacteria. No, to find x given t or to find t given x, we need to have a relationship between x and t. So it's once again getting to that solution kind of thing. But let us start reading from the very first line. It says the rate at which the bacteria is increasing. So I put it in this way, the dx by dt, that's the rate at which the bacteria is increasing. Dx stands for the change in the number of bacteria and dt is the change in time. So when you just put that thing, is the change in number of bacteria over change in time, it tells us the rate at which the bacteria is changing or the bacteria is increasing. It's proportional to the number of bacteria present at that time. I hope that's something what they have given in the question. And to be very honest, this kind of thing has been there in all the sums of differential equation. So basically one sum, I would not say enough, but all the sums then happen to shape up in the same way. So we need to talk nicely on this one single sum what we have picked up under the heading of application of differential equation. Right now you are checking the first thing. The rate at which the bacteria is increasing is proportional to the number of bacteria present at that time. And then I think so it becomes dx by dt therefore has to be equal to, I am so sorry, the dx by dt happens to be equal to k into x, where k is some constant of proportionality. Now this is something taught to me at my school grades. Okay, if x is proportional to y, then x is some constant multiplied by y, where we say the k is called as the constant of proportionality. So probably going aage. Now my target is to what? Is to reach to my equation between the two variables x and t. Now right now I have got a differential equation with me, dx by dt hai, x hai. So somehow I need to get back to my solution. So we need to play that variable separation method. So let's take the dt on the floor and let's push our x ka term on the other side by the side of dx. Variables are separated, your d has come into picture. And then integrating both the sides, we get to what? The log x is equal to kt plus c. Now 1 ka integration with respect to x goes x. So 1 ka integration with respect to t is going to go t plus the constant c. Now we have prepared a sort of a rough draft of a equation between x and t, what you can see over here. So, आप बोलोगे sir rough draft क्यों बोला? No, we at present cannot put in t and find x or put in x and find t because k and c are not known. And I think so that is why they are lending us some more information in the sum to help us to find k and c, which we fitted over here, and that will be the final relationship between your x and t, which you can then start using. You put t, find x, put x, find t. Coming back, I think so we need to go back once again. Once you decide the variables are x and t, let the x be the number of bacteria present at any given point of time t in hours. The only thing what a student should strive is to how to get the relationship between x and t so that we can use it. How to use? We put in t, we find x, we put in x, we find t. For that we need to have a relationship between x and t. So let's start reading from the first line. It says the rate at which the bacteria is increasing, the dx by dt, change in bacteria over change in time. It's the rate at which the bacteria is increasing. Change in bacteria over change in time, it's the rate at which the bacteria is increasing. That's proportional to the bacteria present at that time. So that's proportional to x. So coming back, the dx by dt therefore can be written as equal to kx, where k is some constant of proportionality. Now finally, I am very close to my relationship, getting to my relationship between x and t. How? We are into differential equation, and the full topic taught us from differential equation how to get back to the solution, how to get back to the relationship between x and t. So I need to follow that procedure, variable separation method. For that, the dt needs to be brought on the floors. dt on the floor. The x moves by the side of dx. Okay. We punch in variables are separated, integrating both the sides. So over here integrating 1. So that becomes log x, and then we have got kt, 1 ka integration with respect to t, plus the constant c. Now that's a rough draft. Rough iske liye because I said you cannot find t by putting in x or find x by putting in t because k and c is still unknown. So now I think they have given me few information which will help us to find c and k, and once we know c and k, we are going to fit it over here. That equation will then become final equation for usability or usable equation, wherein you can then put your t and find x, or put in x and find your t. So let's see the first line what they are giving us, the data what they are giving us. The original number n, stop. No, stop in the sense original number n bolega to initially when the time was set to 0, the tray had contained or tray was containing n bacteria. So can I say when t is 0, the number of bacteria present in the tray was n, check. Original number n, mane initially tray mein they had filled in x bacteria. So at time 0, when they had set the time 0, the number of bacteria in the tray was n. So when t is 0, the x is n. Let's put in over there, let's see kya milta hai iske andar. So log of n is equal to k into 0, that's gone, c. So I got my c ka value. So as soon as you get your c ka value, upgrade your relationship mane. As and when you get your c and k, just start fitting in over here, keep upgrading your relationship to commit to the final state. So now my log x reads equal to kt plus my c, I have already found its log n. So we say that's upgradation. Now first upgradation. Still something is left, your k is still no, even now if you put your t, you will not be able to find your x. No, the purpose of setting up a relationship between x and t is what? To use it. How to use it? To put in t and find x, or put in x and find t. That we'll see end mein kya karna hai isme. But still we need to find k. I think so now you need to read the full line. If original number n already used doubles in 3 hours, that's the second information. In time 3, the number of bacteria becomes 2n. So 2n kahan likha tha? Originally the bacteria in the tray were n, and in 3 hours it becomes 2n. It becomes double, it becomes 2n. So in T3 the x is becoming 2n. Let's check kya ho raha hai. So log 2n, it's a simple concept. To find the two unknowns k and c, they had to submit two conditions in the sum which will help you to find k and c. The initial condition was what? At time 0, the number of bacteria in the tray was n. That helped us to find c ka value. And then after that it doubles in 3 hours. That was the second condition given to you. So in t equal to 3, the number of bacteria x becomes your 2n. So we are trying to use that now. Your x is 2n, okay, done. K into 3, we are talking of 3 hours. In 3 hours, log n. Can I shift my log on that side so that I can club the two logs into one log using log ka rule? So that goes log of 2n minus log of n. I hope this is pretty comfortable, equal to 3k. Now we are seeing log a minus log b, we can apply log ka rules. Log of a upon b. So that's going to go log of 2n upon n. Now that sounds good, is equal to 3k. Your n gets cut, and then log 2 is equal to 3k. So finally I can say my k has settled down to 1 by 3 log 2. Now the 3 I pushed over there. Now मेरा वही पेटर्न डायलॉग, के को जेब में डाल के डांस करेंगे. नो सर, आपका वो फाइनल अपग्रेडेशन बाकी है. सो कैन आई पुट माई के ओवर देयर? इफ यू डोंट माइंड, आई नीड स्पेस. So can I push my k ka value in this? Now that's my final upgradation. So log x now reads 1 by 3 log 2 your kk value, and then writing t over here seems to be quite dangerous. Now you yourself may be reading that as log 2t, log of 2t, jabki it was log 2 and the t was separate. So reposition your t aage so that neither you nor the reader happens to misread that thing as log 2t. Now these are few writing nuances what you need to follow, what you get it naturally while practicing more and more sums on that. So that was the final upgradation. Now you can see the two variables x and t in that. You need to put your t, find x, or put in x and find t. Now what they have asked me to do, let's check the last line. Find in how many hours the number of bacteria. But I think can we, Sir ji अचानक झटका लग गया, नहीं झटका नहीं लगा. Can we check the second condition once again, how we got kk value? No, that was nicely poised right now. No, we were very close to the final upgradation. We just had to find k. So we had to search for one more condition in the sum. It stated the original number n becomes 2n double in 3 hours. We haven't used that thing. The t is equal to 3. At that time the number of bacteria in the tray now are 2n. Check that please. And now if I put it back over there, log 2n is equal to k into 3 plus log n. And iske baad I think so things seem to be quite clear. Push your log on that side, you get a chance of playing log m minus log b into 1 log, and that will help you to get your kk value. So we proceed, log 2n minus log n is equal to 3k, and that goes log a minus log b, which we make it सारे log का एक log plus का into minus का upon, I mean to say log a minus log b becomes log of a upon b, log of a upon b, and that's equal to 3k. So n gets cut, we got log 2 is equal to 3k, and then your 3 is parcelled down, you got your kk value. Now the equation needs the final upgradation. So I think we need to go for putting kk value over there. The log x is equal to k is your 1 by 3 log 2, and then I just suggested don't put your t piche so that the reader starts happening to read this, misread this thing as log of 2t. Put your t aage over here and plus log n. So now that's the final upgradation. The only variables now what you can see over here is x and t. It's usable. It's ready to use. You can put in t, find x, put in x, find t. Now we need to read the last question. The way we need to use this thing. They say find in how many hours the number of bacteria become 4n. In how many hours the number of bacteria in the tray becomes 4n. So let's push our x 4n in that. So log 4n, I think you will enjoy this, is equal to t by 3 log 2 plus log n, and I think we need to go for once again the same treatment. The log n can be pushed over there and we can club the two logs. Log of 4n minus log of n is equal to t by 3 log 2. Check that everybody. Now we are seeing log a minus log b, so that can be turned into log of a upon b, log of a upon b. Now n gets cut, you are left with log 4, check. 4 you can write it as 2 squared, check, sorry. And then power falls down, check. Log 2 gets cut, checked. And then the t turns out to be 6 hours. Oh, you missed out. Okay. We were supposed to find in what time the number of bacteria becomes 4n. Let's do it. Push our x 4n in the final upgraded, your equation. So now we get a chance, we push log n on that side for the reasons very well known. Log 4n minus log n, we get a chance to make it 1 log equal to t by 3 log 2. And then I think so log m minus log b, we can play it log of a upon b, that goes log of a upon b, done. Your n gets cut, you are left with log 4, you saw that. Now log 4 you can write 4 co 2 square, I hope I am not doing it clumsy. The power comes down, the power falls down, you can cut your log 2 and then your t is equal to 6 hours. Now honestly, if you are reading the question, you could have figured out 6 hours directly without solving, but that doesn't mean I did happen to tell you you can crack the answer directly. It's 4 mark ka sum, you have to use it, you have to treat that sum as an application of D and you need to solve it in this way to get the full 4 marks. But answer could have been cracked directly. In many sums of your syllabus right now you can do that. just to have a rough idea कि आंसर ये आना चाहिए था, because it takes a long process to reach to the answer. So if you know the answer, you get the answer, you feel that content ka no thing, the feeling, happy feeling, which helps you go in a much better way in the rest part of the paper. It always helps. It's a human psychology. Coming back, the bacteria becomes double in 3 hours. So if I just happen to draw the timeline, I hope this was pretty comfortable. It's worth watching one more time. Mane, you can just rewind and play the entire process one more time where I started this sum, because it's, in my opinion, looking at all the sums, bearing only 1 or 2 sums towards the end in your state board textbook, all the sums follow the same theme. So if you are comfortable with this sum, as in my batches, I knew that, I observed that, I felt it. They got comfortable with the first sum, they were cruising nicely through the remaining sums. You can do it for yourself also right now. But before that, before you rewind and play, just finish off this. Let's finish off how did we crack the answer directly. I have a timeline and I have the number of bacteria. It's a timeline and the number of bacteria. At 0th hour, we had n bacteria in the tray. In 3 hours, the number of bacteria becomes 2n. In another 3 hours, the number of bacteria will become double of this, 4n, and that was the question what they had asked me. Okay, in what time the bacteria is going to become 4n? It's 6 hours. Check, check, check. You missed out, or maybe if you got it and they were stunned, oh gosh, we can crack the answer directly, but not in exam. In exam, you need to project the entire application of DE ka solution in this way in the solution to get the full 4 marks. Coming back, at the 0th hour, the bacteria in the tray were n. They said in 3 hours it doubles. So on the timeline 3 hours, now the bacteria in the tray are 2n. In every 3 hours, it will double. So in the next 3 hours, that means at the end of 6th hour, the number of bacteria will become double of 2n, it will become 4n, and that was the question, in what time the bacteria becomes 4n? It's 6 hours. You got the 6 hours. So you must have enjoyed this, I am very sure about it. My suggestion, if you want, you can just rewind and play the entire process what we did over here. It's a repetitive job which is done in so many rest of the sums in application, and as far as I understand the previous syllabus, which was around 15-17 years back, application of D those days में every year one question of 4 marks on that. So you can take it कि confirm एक question इसमें से होगा, and it seems to be pretty simple. If all the sums go in that way, let me have a good hand on this sum. So my suggestion to you all, to all my viewers across the Maharashtra right now watching me, go through this part one more time, and then I have given you 2-3 more sums in the LMR sheets. You can do check that, and you will surely feel okay, what he was saying was perfectly correct. It's the same thing which is followed in all the same theme of solving being followed in all the sums. With that, we come to the end of the LMR sessions of paper 1. I really enjoyed with you all, and I hope same over there also. Of course, response from that end I cannot get it right now, but I do feel that the response must be really very positive. This is Ashish sir coming to you live on JKSClassesonline.com. Hope we have served you the best in the LMR sessions. Bye everybody.